We are now continuing with part 3 of indefinite integrals, and this part deals with applications to economics. Now, in this question, you are asked to find your total cost function, and you are given the marginal cost function as well as total fixed cost. You know that total cost is total fixed cost plus total variable cost, and your variable cost is a function of Q. Now, you also know that your marginal cost function, which is a function of output Q, is the first order derivative of the total cost function. And your total cost function, here it is also a function of Q. So we need to essentially use this information and obtain our total cost function. So therefore, we're now not working with f of x anymore. Our function that we want to determine, our antiderivative, is now your total cost function. That is now your f of x. And now in between your integral sign and dx, it is now the integral sign and dq, because everything is a function of q now, not a function of x. So therefore, the integrand, which is in between your integral sign and dq, that function is your marginal cost function. So therefore, in order to find your total cost function, it is going to be equal to the integral or the indefinite integral of your marginal cost function with respect to q. So please be consistent with your notation. If it's an application and it is a function of labor or output, use your variables and don't use x if it is an application. So therefore, I'll put in my marginal cost function and I will say it is with respect to q. So now we're going to apply our rules. So therefore, I need to deal with each of these on their own. So therefore, I have my indefinite integral of q squared with respect to q. And then here I've got a constant times a function. So I'm going to take the 2 in front of the integral sign. And you'll have to treat the q with respect to q. And then lastly, you have the integral of a constant. So therefore, q is raised to the power of 2. So that means n is 2. So therefore, it will be q to the power of n plus 1. So therefore, it is 2 plus 1. And I have 1 over n plus 1. And that is 1 over 2 plus 1. So it's simply 1 over 3. Q cubed plus, remember you take the constant in front of the integral sign. So you're first going to integrate what is between your integral sign and dq. So therefore, q is raised to the power of 1. So therefore, n is 1. So therefore, it is 1 plus 1. So that is going to be q squared. And then I'm going to have 1 over 2 times 2. And 2 times a half is just going to be 1. So therefore, I have q squared. 1q squared. Of course, I do not have to write that coefficient. And then here you have the integral of a constant. And now you should know that this is simply going to be 4q. Now, don't forget to add your constant of integration at the end of this. And you are, in fact, given that constant of integration, your total fixed cost. So now you see why it is important to always include that C, because it could stand for something. And here we used our marginal cost function to obtain our total cost function, which is given over here. And we need to add our total fixed cost because our total cost is given by our variable cost plus our fixed cost. And there is your first example. The next application requires that you find total revenue. And again, you know that if you were to get your first order derivative of your total revenue function, you would get marginal revenue. So now you're given marginal revenue, and we need to use our indefinite integrals to get our total revenue function. So of course, marginal revenue and total revenue, they're both a function of Q. So therefore, we have to use Q instead of X. Notice the antiderivative again is given by our capital F, and for our derivative, we would use the lowercase f of q. So therefore, in order to find my total revenue, it is going to be equal to the indefinite integral of my marginal revenue, that is the integrand over there, with respect to q. Here we would have said with respect to x, but because of the application, it is with respect to q. So now you put in your marginal revenue function. I will treat each one separately and then subtract. So therefore, I'm going to have my indefinite integral of this constant 10 with respect to q. And then I've got minus 4q. So I'm going to take that constant in front of the integral sign. So it's minus 4. And then you have your integral sign. And in between your integral sign, you've got q. And then with respect to dq. So we treat these, integrate them separately, and then subtract. So with your integral of a constant, this is the explanation, but it would simply be 10q. Now we have minus 4 times 1 over n plus 1, and n in this case was 1, so it's 1 over 2, times q raised to the power of n plus 1, so that is 1 plus 1, it's 2. So I have a half times minus 4, that's going to give me minus 2q squared, which is what we have over here. And then we say plus c. But in this scenario, if you revert back to your first year micro, there would be no constant of integration. So we indicated in the prior step, but in your final step, your answer for TR would just be 10q minus 2q squared. Here is another example where you are required to find your total cost function, and it is the same as the example 2 slides previously. So go through this worked example. And here is another example where you are required to find your total revenue, and that is where you're given your marginal revenue function, which would be the first order derivative of TR. So you're given this, but now you need to find TR using indefinite integrals. So follow the same method as we did previously to get your total revenue function. Now, this is the step that I wanted to get to. The question just prior that you need to work through on your own, you needed to get your total cost function and you needed to get your total revenue function. Now, you could typically be exposed to a question where it says, right, determine the function for your profit. So what they want is a function, not determine what profit would be, but just determine that function. Now, of course, profit is the difference between your total revenue minus your total cost. So once you've obtained your total revenue function and your total cost function, you can simply say TR minus TC. Note that I always put the function in brackets because each and every sign needs to change. So this will become minus 140q. That will become minus 4 over 30q cubed, and that will become minus 1000. And then, of course, you can simplify so that what you end up with is your profit function. Now, this is taking you back to your first year microeconomics. So there is this assumption that you have this knowledge. We don't reteach it, but you understand the principles of what is going to happen next. So here you were required to get your profit function, but what else could you be expected to do? Right? Now, in this example, you're asked to determine what the maximum profit is. So it's going a step further. So let's go through this one step by step. You're given your marginal revenue function, you need to find total revenue. You're given your marginal cost function, you're going to be required to find total cost. And then lastly, you're going to have to determine maximum profit by first getting your profit function and then determine what your profit would be. So very quickly, your marginal revenue is a function of Q, so is your total revenue. So therefore, to get your total revenue function, it is equal to the indefinite integral of your marginal revenue, which is that, with respect to Q. So there I've placed my marginal revenue function in between my indefinite integral sign and my dq. And now I'm going to have to treat these separately and then subtract. So this is just a constant, the integral of a constant. So I know it is just going to become 240q. And this portion of your marginal revenue function was 0.6q squared. So you're going to take that constant in front of the integral sign. So that is that minus 0.6 in front of the integral sign. Then between that sign and dq, you have q squared. N here is equal to 2, so that is going to become 2 plus 1. 2 plus 1 is going to give you 3. So therefore, in front of my q, I've got 1 over 3. And now I have to multiply it by the constant. So minus 0.6 times 1 over 3 will give you minus 0.2. And I've got q cubed plus my constant of integration. But of course, we're not given anything, so therefore, it's just 240q minus 0.2q cubed. Now for your total cost is a function. You've got variable cost and fixed cost. So therefore, you would be given your fixed cost. And as you can see over here, it was given as 50. If you have a look 2 slides prior. So to find your total cost function, it is a function of Q. It is going to be given by the indefinite integral of your marginal cost function. That's the integrand. Remember, that is essentially that derivative over there with respect to Q. Now, we are working backwards to find the antiderivative, which is total cost. So now I've put in my marginal cost function with respect to Q, and I'm going to treat these on their own. Remember, the integral of a constant is just going to be 150 Q. And now with our constant multiple of a function, I'm going to take the 0.3 to the front of the integral sign, and then first integrate that and then multiply it by that constant. So n is 2, so it's going to be q to the power of n plus 1. 2 plus 1 is 3, so therefore this becomes 1 over 3 times 0.3, so it's going to be plus 0.1 q cubed. This is a typo. This should be positive, right? And then you add your constant of integration. So therefore, you add the fixed cost, which was 50. So there's your total cost function. Now, you need to find profit. So therefore, it is your total revenue minus your total cost. There's your total revenue function. There's your total cost function. So therefore, you're going to get your profit function by saying total revenue minus total cost. Remember, you need to distribute that negative, so all these signs change, and you get your profit function. Now, in order to determine what that profit is, we need to determine Q. So from first year micro, you should remember that to get the relative maximum of your profit function, you need to get your first order derivative of your profit function, which you have there, and set it equal to 0 to find that critical point. So your first order derivative, 3 times minus 0.3 is minus 0.9. It's going to be q squared plus 90. Set it equal to 0. You will get q squared is equal to 100. Therefore, q is equal to 10. We need to check our second order conditions to see that it is a relative maximum. And you should recall that for a relative maximum, your second order conditions must be negative. Remember the smiley face and the sad face. I'm not sure if that's how you were taught. So with your second order conditions, get your second derivative now of this function. So therefore, if I differentiate this a second time, 2 times minus 0.9 is minus 1.8 q. And of course, a constant differentiates to 0. If you substitute the 10 in over there, you get a negative 18. So therefore, at the quantity or output of q equal to 10, the second order conditions is negative. So therefore, this is the output that will maximize profit. Now remember, we determined Q, we didn't determine profit yet. So therefore, we need to substitute this into this profit function, which has been done over here, and then you can determine your maximum profit. Now, here we have 2 home exercises. Please work through these exercises and to test your knowledge, because you'll be expected to do applications, using your micro theory, but using the math tools. And that concludes this topic.